Hi, I'm very excited to bring this video to you. Typically, if you are a software engineer, you can build a website or a page or in a day. But for hardware engineers, seeing your output physically right in front of your eyes takes much longer. And we are working really hard to solve this path, enable this path for hardware and embedded engineers. And this video shows one snippet of what we are working towards. So now enough of the talk. Let me show you how you can port a counter design written in your HDL, Verilog, VHDL to your RISC-V FPGA board in less than 10 minutes. So what we are going to do is take this counter design, okay, put it on this FPGA board and RISC-V board in less than 10 minutes. So this has LEDs. These are the LEDs we'll be using for our counter. These are LEDs for the power. And we'll program our this board using a type B USB port here. Of course, we'll connect our counters, input and outputs. We'll connect our set pin, reset pin, clock pin. From the counter, we'll connect our counter outputs to these LEDs so that it indicates how the counter is running. So I've created a project in this board software. Let me open that project. So this is the project I have created. It's a simple RTL design written in VHDL. You have clock set at set, basically all goes to 0. It's a 4-bit counter. And then when the counter increases, you basically put the output to the LEDs, run through the whole flow in this tool. Okay, so you basically have created RTL. We have created a constraint file for running synthesis, and of course then doing ST as well. We have created test bench as well, which we have verified in the design. So we'll first start with what we known as synthesis for this. So we'll start running synthesis. Then you can run placement. Then you can run routing. For small design like this, typically you can just do it in what is known as one-step flow. In one step, single step flow, it will complete all the steps starting from your synthesis, placement, routing. So this gives a lot of flexibility. You can modify the design, you can see changes in terms of modification, you can modify clock frequency, you can put a RISC-V board. There are FPGA friendly RISC-V core, and you can put those on FPGA as well. So once that is done, you can actually see the reports of your design as well. Let's say you've done synthesis. What is my synthesis report? What is my placement? I have done placement. What is my placement report? What are the inputs I'm using? What are the routing? You can see your STA timing report as well in terms of what are the clocks you had specified. What is a violation, required time, are there a setup violation or a hold violation? So there are no violations. If you change the frequency, of course, you can start seeing violation, but right now there is no violation on this design. Now, once you have created this, one of the important thing is you have to connect your counter pins to basically the pins which exist on the board. And this can be very easily again done with what is known as interface designer. This interface designer, you can see what are the pins available, what are the GPIO pin available. So let's say data out 0, I've connected to one of the pins here, GPIO pin. Data out 1, I've connected to another, and this pin is actually in turn connected to the LED. You can connect this, and then I provided the clock. I connected the set pin to one of the GPIO pin, which I'll use as a set pin, which is connected to the button, and the other set pin I'll use that. So this way I have done now. Not only I have basically created the design, I've created this pins connection as well, and this you can very easily do it using a GUI, using the interface designer. I've done assigned the resources. Next step is basically put this on your FPGA board. So the FPGA board which I've seen you on slide, this is the FPGA board I'm using. My design, so click on tools. I'll say open programmer, and this now will put the bit stream on my USB target. Once I'm done with this, I can see the output happening on the board. So